Hey everybody, thanks for joining us. I'll give it another minute to see who else is going to join, but let's give a little introduction while we're here. This is, of course, my name is Brian Gotzi. I work in AI and AI products at DataStax. Today we're going to be talking about GraphRag and how we can apply that to some movie review data set. Um, so for a little bit of background, and my background in particular is I started in academia in mathematics in grad school, got a PhD working with probabilistic Bayesian models and machine learning models before moving into software startups, building machine learning and then AI models. And then now at DataStax, we work with trying to solve various customer problems with AI tools. And so one of the coolest ones been working with recently is GraphRag. So yeah. This is called Connect the Dots in your graph or in your RAG pipeline with GraphRag and GraphRetriever. So it looks like we've got quite a few people here. Before we get started, I guess, so you guys probably already see the chat. So feel free to make some comments in the chat if you want. I'll try to keep my eye on it. I'm not sure I'm going to keep up with everything, but I'll give it a try. And then if you have some specific questions, there is a Q&A tab to drop a question in there. And so after I go through my sort of planned spiel, I can go to the Q&A and see what questions we have. So yeah, let me go ahead and share my screen. Let's see. All right, picture in picture looks good. All right, I think that looks pretty good. Okay, so what I'm sharing right now is a notebook, and that is one of it's in Colab. It is one of it's linked in the resources tab. So if you go to the resources tab, you can find this notebook. This notebook's also in GitHub and on our GraphRag project page, which is also linked in the resources. So if you want to find this and follow along, feel free. I have sort of streamlined this and set it up for myself before we got started because some of these things do take a couple minutes to process the data and all that stuff. So, all right. But definitely follow along however you want to. And then afterwards, you can go check out the notebook yourself or download the code or anything like that. So, all right. Looks like we got quite a few people here. So great. I will go ahead and get started. All right, so as I said, we're doing some GraphRag here on movie reviews, and the data set comes from Rotten Tomatoes. So Rotten Tomatoes is a website with lots of movie reviews. They've published some data sets on sites like Kaggle and stuff like that. So we grabbed some, and basically we wanted to see what GraphRag could do on this data set. And in case you're not familiar, maybe for those of you in the chat, drop a comment if you are familiar with GraphRag and your experience with that. But GraphRag, just in short, it's RAG is Retrieval-Augmented Generation, and the graph part is a knowledge graph. So the knowledge graph helps aid in the retrieval step, meaning in RAG, when retrieval happens, we use vector search to go grab some documents that match some sort of query, pull them back out, and then we generate an answer to the query based on the documents that we pulled out. Now, GraphRag adds the graph step, which is when we retrieve documents, we can then use the knowledge graph to sort of hop around to related documents that might also help answer the question. So we'll get more into how that specifically works with this data set as I get a little farther down. But as is written in this notebook here, we have what we're trying to do is help answer queries about movie recommendations. So what is a good family movie, or what is one of the most exciting action films, and stuff like that. So just seeing what the reviews say. And we're going to use GraphRag to do this because all of these films, the directors, the actors, the reviewers, they're all sort of connected in this big web of data points. And so we can definitely use some of this supporting information to help us answer the queries and make better movie recommendations. And so the strategy we're using here is basically we're going to rely on, well, GraphRag itself, but specifically we have this object called the GraphRetriever, which the documentation for that can be found in the resources under the GraphRag project. And so that link is here in the notebook, and the link is also in the resources here for this live stream. And so the graph retriever is sort of a layer on top of your vector store. So if you have documents stored in the vector store, you can basically instantiate the graph retriever as a Python object just to sort of explain or what do you call it? Like set up how the graph is going to be traversed over the data points, the documents in your data store as we do the retrieval step. So I see a question in the chat. So I'll explain how the graph step works when we get down to it at the bottom. So that's a good question. Let me know later if I don't actually answer that question as part of the talk here, or feel free to drop in the Q&A. Also, I'll get to it at the end if I somehow miss it in the middle. All right. So so this is all basic stuff at the top of the notebook. We're installing the packages. We have the LangChain graph retriever here is kind of the key thing. We're also using Astra. Astra is a DataStax vector store. It's got a free tier. You can just sign up and get your API keys and get some free cloud storage for vector store. And all the information for setting it up is linked here in the notebook. It's also linked in the resources in this live stream chat, or in the resources tab of the live stream. And it's really easy to sign up, get a key, and then just create a vector store and start storing stuff there. And so it's really fast and obviously scalable and all that stuff. So we're using Astra as the main storage tool here. We're also using in this notebook, it's OpenAI. So the OpenAI, you would need an OpenAI API key in order to use the OpenAI embeddings, and then also to generate the final response. So the LLM, the embeddings and the LLM in this notebook come from OpenAI. So you would need a key for that as well. So that's all that information is right here in the notebook. And then there's a little bit of just general stuff about loading your environment variables, such as your OpenAI keys and your Astra keys if you're using that. All right. As for loading the data, this data comes from actually direct from a Kaggle project, and there's a bunch of movie reviews, and there's also just some basic information about the movies. And so the movies that are reviewed are obviously referenced in the reviews, and so that's one of the ways that we can connect data points together. I'll get to that here in a second. Okay, so this, as I said, we're using Astra as the main data store. However, if you want to just do a really fast, really quick run through of this notebook, you can. I did embed directly in the notebook a very small data set of reviews. If you're an Addams Family fan, there's all the Addams Family movies in here. But you can just run through here without the Astra API key and do a super small but super fast demo of that. Of course, if you're just looking for recommendations, you want to look beyond the Addams Family movie set, but this is just so you can try stuff out and see how it works. You do still need an OpenAI key for this because of the LLM generation step and the embeddings. So just if you want to run through it really fast, there's a data set already embedded there. But the more fun part is definitely to load the full data set. So I have already done that. It does take a few minutes depending on how much of the data set you're loading. And so I've already gone through and just went ahead and created an Astra database. I put my API keys embedded or have them in the environment variables, and I have loaded some data into the database, all of the reviews and movie information. And so that's what these few cells do here. And I did take for our purposes here. So when you have like this data set is pretty huge. So basically, loading would take a long time if you do everything, but also generation takes a long time, and graph traversal takes a long time if you want to do literally the full graph, the full data set. So, yeah, I took the top 50, just the top 50 movies. And as you can see here, this is the number of reviews for each movie. So the top movie is Parasite, at least in this data set, and it has 954 reviews. So there's quite a few. These are the most reviewed movies in this data set. So just for reference, that's what kind of we're looking at here. And so then let's see right here. Yeah, we're just subsetting based on the top movies so that we load, just the ones we need, and or just the ones we need. our subsetting data set just to save time for the demo for the most part. And so that's what that stuff does. Right here, here's this step here. It is the setup of the AstraDB vector store. So this is the object in Python that connects you to AstraDB and allows you to, like, using those Astra API keys that I mentioned before, you can connect to that database through this object here. And so this is, pretty standard database connection stuff. But if you haven't used Astra before, this is a super easy way to do it. And I have this little pre-delete collection here because I've been doing lots of demo versions. And so if you need to just like empty the database and recreate it again, that's what that's for. But I did not want to empty it the last time I created it, so I have that commented out. All right, so the way that we work with Astra or other vector databases is, in general, we would take the CSV file, load the data, and we have it parsed out and all that stuff, and then we would convert each review and each movie into a document object that we can then store in the vector store. So we then embed it into the vector store so that it's then searchable using semantic vector search. And this right here is just sort of like basic Python code that converts each of the movies, each of the reviews into a LangChain document object, which works really nicely for just storing straight into the Astra and also other vector databases as well. So that's a basic just sort of data management code. As you can see here, I loaded over 24,000 total documents. So it's not a huge data set, but it's not small either. If we just look at what one of the movies looks like in the database, this is what that looks like. Just the general, we have for the movies themselves, we have the director, we have the genre, we have language, rating, all this stuff. These are all things that, like, in particular, when you're asking yourself, okay, if I want to recommend a movie to somebody, what would I use? And naturally, genre would pop up. Sometimes director. Some people like directors, or certain directors a lot. All of these things could be useful for making recommendations to a person who asks naturally. And so it seems like it would be reasonable to say, let's connect these things in a big graph and make recommendations based on things that are connected. If it's movies by the same director, maybe we want to make recommendations based on that. So connecting these data points and connecting movies that have the same director or the same genre or the same reviewer, maybe the person who's writing the reviews, maybe they recommended 2 movies and you trusted their recommendation last time. So this time you want to also get another recommendation for them. That would also be a good use case for GraphRag, because we can connect all of these things in ways that just vector semantic search doesn't quite do. Okay, so here's the one-liner that does, we have the documents already created before, we're adding them to the vector store. So this is putting them into Astra. And as I said, I already did that. That takes, could take somewhere between a few seconds and a few minutes, or even more, I guess, depending on how many documents you're actually loading in there. Okay, so we are now up to the GraphRetriever step. So this is sort of the most important thing. I kind of went pretty fast through the beginning of that because it's all pretty standard if you're familiar with the data set and with AstraDB and vector stores and all that stuff. So GraphRetriever is kind of the new thing. It's been around for several months now, but it's sort of a new-ish, new this year way to set up GraphRag. And so we designed it to be super lightweight, and so it makes things really easy. We don't need to build some big knowledge graph that takes up space and uses all of these extra query languages and whatever else to use it. So the GraphRetriever itself, it sits on top of your vector store. So it's like you can already have data in the vector store. You don't need a separate knowledge graph, really. You just need to configure the GraphRetriever to traverse inside your vector store in the way that you want it to. And so in the graph, we have an implied graph, which means the graph doesn't actually exist. The graph is just defined by the GraphRetriever, and the GraphRetriever knows how to hop around inside the vector store, which is kind of cool and lightweight, makes things actually super simple. And edges, in this case, edges in the graph, the connections between things, are defined like this. So this is one type. So this says, if you look at a document in the vector store and you look at the field for a reviewed movie ID, And if the reviewed movie ID is the same as another document's movie ID, then we would connect them. So in this case specifically, it says, if we're traversing the graph and we have a review, if the reviewed movie ID in the review, it'll jump directly to the movie ID. So like basically it's a lot of ways it says like, if we configure the GraphRetriever this way and edges this way, this means that we can jump directly to the information for the movie that was just reviewed. That seems to be like the most natural and simple use case for this sort of thing. We can go way beyond that, and I'll get to that in a second. So yeah, basically I just said all of this stuff. And the strategy. So if we're defining the graph retriever, we have to define the strategy. And in this case, we're using the eager strategy, which is the simplest one. It basically just says, we're going to start with a certain number of documents, in this case, 10. And then we're going to jump from each of those. We're going to get 10 more in the graph. So as the edges, so we're going to jump as the edges are defined into the next 10. And then we're going to say from the maximum, the total maximum, select K is going to be 100. So the maximum number we're going to get back from the total retrieval step is going to be 100 if we define the strategy this way. And max depth means how many hops do we take inside the graph. So from our starting 10, we're going to make one hop if the depth is 1. And we'll look at deeper depth here in a second. So, all right. So this is what it looks like in actual code right here. It's like we import the strategy and graph retriever, and we define right here. We say, okay, so this is what was just above. It says let's connect every review to the movie that was reviewed. And this one actually goes backwards. So this says, let's connect every movie to every review of it. So we actually have 2 different types of edges going in different directions. And that makes a difference, as I'll show you in a second. But let's see, let's sort of like theoretically or like hypothetically run through how this query is supposed to work. So if we have the initial query is, what are some recommendations of exciting action movies? So what we want this to do is say, okay, let's search through all the reviews, semantic vector search, just like what matches this query. Let's find, some number. In this case, 10. Let's find 10 reviews that say this is an exciting action movie. And then once we find those reviews, we want to connect that directly to the movie information corresponding to those reviews. And then we can pull the movie information into the reviews and then pass that along to the LLM to actually answer the question of what is a good, exciting action movie. So that is a super simple application of this, and it feels a lot like a relational database sort of data store sort of query, where we're saying, okay, well, we know we have these reviews, but like when we're querying for reviews and getting recommendations, we also want to just like join in the movie information. That's super natural, right? And so if we just do that one step, so the max depth, if we do one graph step traversal, we find the reviews, one step gets us to the movies, and that's what we have. So that's what we're going to try first. So basically, if we go ahead and run that, we have the graph retriever set up. That took basically 0 seconds, because all we did was say that the graph retriever is defined this way. We do say the vector store is here, but we didn't actually build anything. We didn't build a graph. We didn't store anything other than saying the graph retriever now exists, and it's supposed to do the eager strategy with these parameters. And so once we define it that way, we can say, all right, so let's run the query and see what we get. And so here we go. This is just the raw output printed out. And so we got a bunch of movie reviews here. I guess, well, a bunch. It's 10 movie reviews. Oh, and one movie itself, saying, so this movie review is very short. It says it is one of the best action movies. So clearly, that's a good way to, or a good review for what we're looking for exciting action movies, and a lot of these other things. One of the best action films to come around in years. I mean, these make sense, right? Okay, so those are the raw results that we're getting back from the retrieval step. And once we go down here to, okay, so this is just some formatting basically. So we're going to go ahead and like sort out the movies and the reviews so we can look at them all nice and together. And so this is not there's no generation yet. So this is before the LLM looks at any of this stuff. So we basically just got the retrieved movies and reviews. So we have the reviews that we found with the initial step. We hopped over to the movie information, joined that in some sense. And then here, I just, in pure Python code, just went through and sorted out the items and printed them out in a nice format that we can read. And so you can see Mission Impossible, Fallout is in here, Mad Max Fury Road, Star Wars, and including the reviews. And there's a bunch of short reviews in here, but they all sort of make sense as being important for finding good. Let's see, sustained endorphin rush is definitely an indicator of an exciting action movie. So that's a good match for our query. And so if we take this and throw it into an LLM with this prompt, and so I went ahead and just said, hey, here's what I want the output to look like, and go just list the movie, tell me how many reviews you are basing it on, give me a little summary, and then maybe throw some direct quotes in there to just help us decide, basically help us decide on this list of movies. And so this is the prompt that I designed, by the way. I guess I mentioned that. But so I just said, answer the query using using the reviews that we collected, and then throw it out in this format with some examples here, pasted the initial prompt, and then movie reviews, all the information from below. So this movie reviews thing, this placeholder here, is actually all of this stuff up here that I just printed out. And then, so if we just go ahead and just have that prompt design, you can fiddle with that if you want, depending on what type of information you want to recommend movies, but this one seemed reasonable to me. There's all sorts of ways you can do that. But if we go ahead and run this, then the LLM, this is sending out to OpenAI, and the LLM is taking all the information in the prompt, which includes the original query. It includes the movie reviews we collected via GraphRag or via GraphR, graph retrieval. This is the G in RAG right here. This is the generation. And there we go. So it just, based on 6 total reviews, it recommends Mission Impossible, and everybody agreed that. And the same thing, well, Mad Max only had 1 review, but it was very positive. And so, here we have some output. So this sort of makes sense. This is just, we all, for those of you who are used to doing RAG, it's basically, searching for reviews. Reviews are just documents with words, and we can do a semantic search there. And join in the movie information, and then have all of that information there for making recommendations with LLM. So that one's the super simple. It's just, remember, it's a max depth of 1, meaning we just do 1 graph step in the traversal step. So in retrieval with the graph, it's just 1 step. Even more interesting than that is if we decide to go a little bit deeper. So this is when GraphRag actually gets pretty cool. So that was pretty cool, useful, lightweight. You don't need to add anything to just join in information. So just like basic joining information to each other across a vector database is super easy if you have it configured well, and it's lightweight. But GraphRag and particularly the graph traversal is more powerful than that. And so here, if we, like I said before, we can define 2 different types of edges. And here we can connect the reviews to the movies that they reviewed, but we can also connect the movies to all of their reviews. So I limited that to 1 step before, but if I just go up more to 1 more step, what this does, like the theory here, is to say, okay, so instead of just saying, find me reviews and then give me those reviews back and also add in the movie information. Sorry, I see some questions in the chat here. So edges are important. That's a good question. I can go back if I went too fast through there. So in a vector database, we generally speaking, we have documents that are all the text is embedded, and it's good for semantic search. So you can answer queries like just the plain question, what are some exciting action movies? And then plain old vector search will retrieve for you the reviews that mention exciting action movies. That we can do. Edges connect those documents, those reviews, to other data points in the database. So in this case, in the first step, what I've covered before, the first version, we connected the reviews to the movie that was reviewed. And then once we have the movie information, like the full movie information, the director, the actors, the genre, all that stuff, we can do more with that if we want to. So it's basically just connecting the reviews to the movies, because the reviews themselves do not have all of the nitty-gritty specifics about all of the movie information. So it doesn't have the genre, it doesn't have the director, and all that stuff. And so we want to join that in. So that's a very relational join type situation. And so that's an edge. An edge goes from a review to a movie in that case, and that's how we defined it right here. Reviewed movie ID to movie ID. So that's the one type of edge. And so when we do retrieval, we go and we find the semantic matches, and then we do one step, one hop in the graph, one edge to get to the movie information. Now, what I just was about to do was to switch to max depth of 2, which means we're doing 2 hops in the graph. Now, in this case, it becomes sort of even more important how we define it, because we're sort of jumping through the graph along these edges, and edges are all connecting things that in some sense naturally should be connected. So we already connected reviews to their movies, and now we're going the other direction and saying, let's connect the movies back to all of their reviews. So the reason why this is important is because maybe in our reviews, we want to say, okay, we found some good reviews that say this is an exciting action movie. But what if other reviews say the opposite and say this is really boring? So it's possible that semantic search would find a review saying that Star Wars is boring or something like that, but it obviously might get left out. So what we want to do, the point here is to say, let's connect the reviews to the movies, and then also connect the movies back to all of their reviews, so we can put these reviews in context. Then we get the full context of all of the reviews in order to make better recommendations. And so just because 1 or 2 people says something's exciting doesn't mean that's necessarily true. It might be true. Reviewers tend to agree on stuff, I guess. But we can say, hey, just because 1 person said it's really exciting doesn't mean we want to recommend it if 9 other people said it's boring. So the 2-step version, the 2-hop version, max depth of 2 in the parameter set here, says we can go from the reviews. Let's say 1 reviewer says it's exciting. Then we jumped over 1 edge, make 1 step to the movie information, and we can pull in all the movie information. And then the second step in the traversal is we pull in all of the other reviews for that movie. So now we have the context, so we can put it in context and compare other reviews to the original review. So let's try that. So this is, let's see, did I do that already? Okay, so yes, I just set up the GraphRetriever again with a max depth of 2. It's still only pulling 10 reviews originally. So just for saving time here, it's only going to pull the 10 best reviews that match the query. So what are some recommendations of exciting action movies? So it's going to pull 10 reviews. And so yeah, and then it's going to hop out from there. So once we do that, we're going to get a 2-hop graph retrieval here. So we're going to get those 10 reviews plus all the movie information plus all of the reviews for those movies. And there they go. Took 11 seconds. More results this time. And then, so previously for the max depth equals 1, we had these are the reviews that came back, the main ones. And if we format that again, we see we get a lot more reviews. And so each movie now has a lot more reviews. So you can see here, like if Mission Impossible had some really good reviews, which it does, rates an A+ when it comes to rousing action sequences. If there's one in here that says it's boring, then we're going to get that too. And then the LLM can then be like, oh, no, actually, these other people said it's boring. And so these are a bunch of reviews for those movies. You can see Star Wars has more reviews. And so once we pass all of that information through the same prompt and say, okay, now let us know what you think of these reviews, and generating that and sending that out through the LLM at OpenAI, we're going to get back another recommendation or more recommendations based on more reviews. And it's essentially all of the reviews, not just the positive ones. So if somebody says the opposite or something else, and so now we have 50 total reviews, but 48 agreed Mission Impossible is exciting. And here it's 23 out of 25 reviews said Mad Max Fury Road. And so, yeah, so this is, I think like to me, this is kind of exciting. It's like not only it's not groundbreaking in the sense that we're discovering something. Like you can write other code that will go find reviews that say exciting things and connect them to other stuff. But like this is really lightweight. I mean, I think if you go through the notebook, I mean, as I just did, it's really easy to just set up the graph retriever to sort of go through the vector store document by document, and like things that are connected will be discovered in the retrieval step. And all you have to do is make sure that your metadata, like the movie, the reviewed movie ID or the movie ID or the director, just make sure those are set up as metadata in your vector store in Astra, and it works really well. And then configure the graph retriever, and that's it. It's super lightweight. So it's like in contrast to a lot of things. The reason why we're emphasizing that is because a lot of the knowledge graph and GraphReg tools that came before really focused on building a big knowledge graph. And we realized we don't need that. Generally speaking, we just want to connect data points that should be connected. And lots of connections, like I keep emphasizing, I know, genre and director and whatever else, like these are things that may not be discovered by a semantic search. So if you say, what is a good action movie? That doesn't necessarily, or probably doesn't make use of the director when making recommendations. But if you want to use the director in your recommendations, then you can simply say, we can create a new edge type that says, movie to director, and then back to reviews again. And then we can connect, this director has great reviews, or any of these, basically these things that are like sort of natural connections. Like if you just think about it as a human, like you might, as a human, look at the director and say, oh, I like this director, so I might like this movie. If you define your edges to connect movies from the same director, then GraphReg will pull them all in and allow you to make recommendations like that. So it just depends on how you have your GraphReg or your graph retriever set up with edges. And then obviously you need to have your query prompt here at the end, just sort of make note of that. So yeah, I think we can try it again. Let's see, let's run through one more time with, I actually haven't, well, this is the type of thing to do something live, not for the first time, but I haven't done it in a little while. Let's try the family movies and see what happens. So if I use the family movies as the initial prompt, we're not going to get Mission Impossible back, I hope. That seems like not the type of movie we're looking for right now. And so let's see, Toy Story, Little Women. Yes, these are good candidates. Sounds like Toy Story is definitely a popular series of movies. And then we can look here. Oh, Star Wars makes it in this one again. Ant-Man, that's a good one. Let's see what we can get. What's the big ranking here at the end? So if we just say, remember this was, what is a good family movie? We went in, it found reviews that mentioned good family movies. It pulled in the movie information, and then it made that second graph step to pull in all the other reviews. And so it could put the reviews in context. And so these are not necessarily in order of like what the LLM thinks is the best one, but it does inject a little opinion in there. So Little Women, Toy Story 4, Ant-Man, these are all, yeah, no, I have not seen all of these personally, but I think they seem like reasonable recommendations. But yeah, I think let me check the chat. Let's see. Okay, so I'm just looking at the end. I maybe missed something. So if I missed your question, please, please just drop it in the Q&A if I don't get to it on chat. But so this last question, thank you, Georgetta. So you can define multiple graph retrievers on the same DB, connecting different info. Absolutely, that's one of the coolest things about this. It's so lightweight. You don't actually need to build a graph. You just define the graph retriever. And so in different code bases, or even in the same code base, you can define different graph retrievers with different edge sets, different strategies, and then whichever one you want to use. So if you want to use your graph retriever that really looks at director to connect things, you can build that one. If you want to build one that is based on genre, you can build a graph retriever for that. Or you can also have all of them in one. You can define all of the edges in one graph retriever if you want. But if you have separate types of questions, you might want to use different types of different graph retrievers, and they can be built like that. It really is like setting up a graph retriever takes, I mean, in the notebook, it says it takes 0 seconds. And so it's basically just creating the object, and then it takes the time when it's doing retrieval. So retriever already takes some time in the standard vector store. But graph a graph is an extra step. And so taking one step in the graph is actually really fast. So it's retrieving with graph is not actually much slower at all than just retrieving without a graph, because it's just, semantic embedding and search is kind of heavy in terms of computation, but just taking one little step between connected items is really fast. So it is pretty very lightweight and very fast. So you can define anything you want, and then just create a graph retriever for whichever purpose you need, and create 10 of them if you want, and then use them in various ways to make different types of connections. One thing I forgot to talk about actually is I mentioned the eager strategy here is kind of the simplest one. And it basically says, okay, we're just going to start with a certain number, and we're going to make some hops from that number, and then we're going to pull those back in. And of course, we're going to limit the total number so we don't explode into like 3 million results or something. And that's eager strategy. There's other strategies. Check out in the resources tab, there's a link to the GraphReg project and the Graph Retriever. And so the other strategies that are there allow you to do more of the re-ranking. So that's really popular, is when you're doing graph retrieval and sort of spreading out in the graph, sometimes you want to say, okay, we just pulled in 100 or 1,000 more documents, but we have a way we want to re-rank them. So there's like how good it matches the query or various other parameters. There's all sorts of configurations you can use to do something more sophisticated than just this eager strategy, because the eager strategy really is the simple or the greedy strategy in some sense. But there are other strategies in there too. So check those out if you want to get a little more sophisticated with your graph traversal. Let's see. That's a good point. Yes, you can use AI. I think like traditional GraphRag has used the sort of extraction triplets. So you can go through documents and pull out entities and names and keywords and build knowledge graphs around that. Like that's totally still doable. Yeah, we tried to make this like, the idea of this graph retriever is to say, it's really flexible. And so you can just define it however you want. And if you want to use AI to create some new nodes and connections, then definitely. Let's see. All right, I'll jump into the Q&A just to see what we have here. Let's see. Okay, so the first question I see. Let's see okay, so is it possible to reference the document type when defining an edge? And so with this example here, yes. I mean, I think it's basically like if you're going to want to connect something, then just make sure it's in the metadata. And so you're right that like connecting movie ID to movie ID could be, let's see, self-referenced documents, sort of. Let's see, what is the example here? I will say one of those in this notebook, I renamed, so both the reviews and the movie data sets are two different CSVs. They both have an ID column. So I named one movie ID and one reviewed movie ID, because then we can tell them apart in the data set, because ID is not a very informative name. Movie review. I think to answer your question, so I think so this is a question from Jim Tyhurst. I think we're doing that already, but maybe I don't fully understand the question. But yes, I think just either by renaming the columns and like the metadata fields, or like we do in the notebook, or by making sure that your namespaces don't overlap. I think that's kind of the key there. And as you know, that like in this data set, if you have two different columns that say ID, but it's reviews ID and movie ID, it's having them overlap in the same namespace is not a good idea. So that's why we renamed them. And it's sort of some basic, data engineering stuff that, unfortunately we still need to worry about for sure. But it seems to be a pretty easy step as long as you just think about it beforehand and make sure that your fields in the metadata are named well. All right, let's see. I'll go all the way to the bottom. Let's see. Let's see. So all the way I guess the oldest. Yes. Sorry, I'm going through the questions here. So what are some recommendations to visualize the graph? Honestly, that's not my area of expertise. I don't know. Maybe somebody else can drop in chat some recommendations for visualizing knowledge graphs and stuff. I know there's plenty of visualization tools out there. We haven't used them heavily for this, We're mostly looking at, passing through to the LLM and making sure that we get good results. But it is fun to visualize some graphs sometimes just to see what's connected. Okay, let's see, Lawrence. Will the knowledge from graph constructed from the document database, does it include some specific entity detection like NER? So this one here, so like NER, a named entity recognition, or sort of, this is sort of like what I'll say classical way to do knowledge graph building for GraphRag. And so building knowledge graphs has been around for a long time, but since AI sort of came onto the scene, there's a lot more tools now for reading documents and saying, here, this is important, like a place name or a person name or a keyword or whatever. And so there's a lot of these entity recognition software things out there. And they have like entity extraction and we can build knowledge graphs this way and like specify relations between them. And so those can be really cool. And we do not do any of that here. In this specific notebook, we don't do any of that, but we have other demos that do use like Gliner and some other tools to extract entities, and then we can use those to connect. So basically what we would do, it would be almost like a pre-processing step. So we would use NER or any tool that would extract entity and then add that entity to the metadata. So we can say, here's a list of names that are included in this document, and then we'd have that in the metadata. And as long as you load your document with that field as metadata, then this becomes really easy. Like set up your GraphRetriever and say, if this person is named in a document, then connect it to that same name in other documents. Like that is, if you've already done the named entity recognition, which is not part of the GraphRetriever project, if you've already done that, you can include it as metadata and then absolutely make use of it in your graph retrieval step of GraphRag. So I hope that answers that question. GraphRag accuracy. That's a good question. There's a lot of ways to evaluate GraphRag. I think that's a much bigger topic than we can cover right here. It's definitely a good question. So I feel like a lot of people who have tried to prove, and including us, have tried to prove that GraphRag is better than normal RAG. It's kind of a struggle. It's sort of like saying, is GraphRag better across the board by some absolute metric? It's sort of like you get a mixed bag. Sometimes you get good results, sometimes you don't. And honestly, it's more, I feel like this is like an intuitive thing. Like you just know that by connecting a movie to its director is going to be helpful for answering certain types of queries, right? And so it's not going to be helpful for answering all queries all the time. It's just going to be helpful for some queries sometimes. And so you just sort of, in that sense, that GraphRag will help you. If you and your users are thinking about connecting a movie to its director, and then also you want to connect the movie to all of its reviews, then GraphRag is for you. And so in that sense, you can design a problem where GraphRag is absolutely going to blow normal rag out of the water. But that's because the problem was almost built for GraphRag. And as this demo here, if you just use RAG on this same query, you could absolutely design a metric that would say, yeah, we did not get the information we needed. But most of the RAG evaluation pipelines, they don't really show that. So it's kind of a mixed bag of saying, how do we evaluate this? It's sometimes unclear by the overall RAG evaluation metrics, but intuitively, and when you have a very specific use case, it becomes very obvious that GraphRag does a good job of connecting data points to each other. So I hope that helps answer that question. Okay, so next question: would it be meaningful for the edge to carry a weight? Yes, I think so. If you check out the different strategies besides eager, it's sort of like there's some options in there that feel a lot like weights. So basically, you can prioritize certain connections over others based on things like MMR and other strategies that are just sort of more probabilistic and more matching the initial prompt and all that stuff. And so definitely the re-ranking based on criteria, which feels a lot like edge weights basically. That is, check out the documentation and yeah, let us know if there's something you're looking for in particular. But it's yeah, definitely just the sort of dumb strategy of connecting to everything and then just pulling it all back is not for every use case. So we definitely want some opportunity to re-rank and prioritize connections over others. The text embedding 3 small. Yeah, I mean, I think it depends on your use case. Sorry, the question is this embedding, the embedding we use here, is it good for embedding reviews, review metadata? So, I mean, this is the one we're using. It shows the demo well. Depending on how sophisticated you want to get with your queries, it might make sense to use a more sophisticated embedding or a different type of embedding. But for our use case here, it seems reasonable. We're asking pretty simple questions like what's a good exciting action movie, and it seems like this embedding was pretty good at just finding those reviews. So we think so, but maybe you have a more complex use case that it doesn't make sense for. You want to get more sophisticated than that. Let's see, next question. Can we use these reviews as filter along with movie embeddings and directly use LangChain to query from AstroDB vector stores? Let's see. I think so. If I'm reading this question correctly, so why do we need, or what's the advantage of using GraphRetriever instead of just a vector store retriever in LangChain directly? So the base vector stores in LangChain don't have the graph capabilities. So if semantic search alone solves your problem and you just want to find similar documents, then that absolutely works. If you want to do graph traversal, and so you have connections, and in this case, we talked about movie reviews here, and connecting movie reviews to the movies, and then back to other reviews again with the steps. Like one of my favorite no-brainer sort of GraphRag use cases is when you have, let's say, like a wiki. Like Wikipedia has links to all sorts of documents. So like this Wikipedia page will have links to other pages, and drawing an edge but from a document or page in Wikipedia to other documents that it links to, that to me is like a no-brainer application for this as well, because you guys know when you're on Wikipedia, sometimes you're reading something, and in order to answer your question, you have to click on a link in order to get more information. And so like that's exactly what GraphRetriever does, is it goes in, it finds the main document that might answer your question mostly, but then it has details that are only in the other documents if you click the link to get more information about it. And so if you're ever in Wikipedia trying to find an answer for something and you end up clicking on a link because you need more information about this specific thing, that's exactly what GraphRetriever was built for. I mean, the links or the connections, via movies and all that stuff. So that's like another use case, like using these hyperlinks between documents is another use case that is covered by GraphRetriever that isn't necessarily going to be covered by a general vector store retriever that does not use graph. And, I like our GraphRetriever naturally because it's so lightweight and so easy. I haven't seen another one that's so easy to use. So that's kind of like, it's not necessarily any better or high performance than some other things, but it's just like way easier to use because we were sort of, a little bit tired of putting in a lot of work to set up knowledge graphs and all this stuff, and just sort of making the most lightweight GraphRetriever possible was a goal. And so that's how we use this. All right, let's see. All right, next question. Oh, basically max depth should always match the length of edges lists. Yes, I think so. If I understand the question right, it's max depth is how many steps you want to take in the graph. And so you sort of have to conceptualize the problem in order to decide how deep you want to go. So in this case, we knew we wanted to go from reviews to movies and back to reviews again. So that's just one step and then 2 steps. So that's max depth in this case, because that's how we formulated the problem. But depending on how your data is set up and the question that you have and the query that you have, it's always how many steps you want to take. And so you just have to conceptualize, like, what are my edges? What do I want to be connected? Then I define my edges that way. And then we say, well, how many steps do I need in order to get to the things that I want to see? And so it's like sometimes if you have a very complex query and you want to know, like, I want to know exciting movies with, popular horror directors or something like that, then you might need more steps because you want to go through the horror genre. You want to go through the directors that are commonly associated with horror movies. Then you want to find the good ones. And so there might be a little bit more here. And so there's not a really super well-defined way to say, how many steps should I take in my like max depth parameter. But if you conceptualize the problem and just think about what you want to do, then usually it becomes clear how many steps you would need to take in the graph in order to answer the question. All right, let's see. I think, oh yeah, I already answered that one. Let's see. Next question. Will the storage attached indexes get created for nodes? So in this case, so there is no, so for storage attached indexes and for vertices and edges in a graph, we don't build a knowledge graph in this one. So the vector store itself just uses the embeddings, and it's just a standard vector store. I mean, there is no added graph element to the vector store itself. So no indexes get updated. Edges are not even stored, honestly. So there are ways with conceptually it feels like edges are being stored, but the way the graph retriever works is that you define graph retriever, and it's defining a way to traverse the data set. It's not defining a graph, but it feels like you're defining a graph. You're defining a graph, but you're not building it. And so nothing needs to be updated as long as the metadata on your document. So you have these stored documents embedded into the vector store, and they have, you have metadata that is not embedded. So it's just pure metadata, human readable, not embedded into some embedding vector on top of the documents. Then you can just hop basically from point to point. And so that is, even without indexing, really, that's faster than embedding, and it's faster than querying. So we don't really need, it doesn't add any overhead really to just define how to hop between metadata points, because anything that is sort of not AI, there's no embedding involved in the metadata, and there's no LLM calls involved in the metadata. So we're really just hopping around in a very lightweight fashion. And so you don't need to build any sort of new data storage to store anything except for the metadata itself. So edges are not stored explicitly, but when you define an edge, it is used in that way. So it's sort of like in the one example we have in the GraphRag project, we call it lazy GraphRag, and Microsoft did a similar thing before, but a much heavier, like less lightweight version, where lazy, in this case, it's kind of a bad word, but in lazy loading and lazy execution, it basically says, we're not going to do anything until we absolutely need it. And in this case, we're going to do graph traversal. At the last minute, we're going to say, oh, what are our edges? And our edges are defined this way. Like, where are they? And then the graph retriever says, oh, these are where the edges are. Like, they weren't stored, but it just says, oh, let's connect these two data points. So that's an edge now. And so it does it kind of last minute, and it's very lightweight and compared to LLM calls and all that stuff. So it's actually really fast. All right, let's see. Next question. It's a good point. Let's see. I think, Bill, you have a point. Yes, I think, yeah, it's a point just to remember to use the same embeddings for querying that you did for from the original data embeddings, and that makes sense. I think that's in response to someone else. Sorry. Okay, Andre. So I can limit graph retriever to certain columns only. If you want to have a column for language and you want to return German language only, let's see. I'm sure there's multiple ways to do that, but I think yes. I'm just trying to think. I feel like that you probably do that on the query level, but you can also do that in the connection level too. If you want to make sure that's like the filtering. I feel like that might just be a query by metadata. We can just basically, we don't even need to use any sort of vector embedding there, and just say, just look at German language and filter sort of on the query level. But there's multiple ways to do that. So definitely connecting movies to languages and then like afterwards filtering those, that would be another strategy. But that of course means you would pull back some results and then filter them. Whereas the more efficient way would be to query on the way in. So make actually your database query itself has metadata as in language German only. So there's a few different ways to do that, but I think that it shouldn't be a problem with Graph Retriever, but also I think you can do that without Graph Retriever as well. Visualization. Oh, thank you, Bill. Yeah, using D3 inside of Carbine. I have not used Carbine before to visualize graphs, but that's a good recommendation from one of our viewers now. D3 within Carbine, and Carbine is spelled with a Q, so Qarbine. Next question, why can't we use DSC graph directly versus dataset AstraDB with GraphRetriever? Yeah, there's different development cycles for the different data stacks products. So without getting too much into roadmap and whatever else, there's just some they're not always in sync with each other. So if you have any specific questions on how you do something with DSE graph versus Astra, just like shoot us a question or an email or something after the live stream, and we can hopefully get to the bottom of it. I'm not an expert on the DSE graph side, so I probably would ask somebody else for a better answer to that. Let's see, next one. Cool. All right. Another question: is there a way to apply a preference boost in the vector query? Let's see. Versus what code in there? Like if you want to prioritize the movie similarity score or weighting different movie ratings like PG-13 over G. There's definitely ways to do that. I'd have to look to see what the best way is. Again, I think there's a few ways to prioritize things. Like re-ranking might work inside the graph retriever, but I think you probably can also have some preference inside the vector query itself. But yeah, that's probably a bigger topic. I think we have only 3 minutes left. So that is a good question. I wish I had a short answer for that, but I think the answer is yes. I think the question is just like, which way is better? So let's see. Last question, I think. What kind of real relations would we like to encode in the graph for multilingual documents? Ooh, that's also a big topic. I think if you have multilingual documents that have a common embedding, so they all kind of go to the same place, and so it doesn't matter what language they are, they would be in like semantically the same space. It depends on what your query would be, but I think there's all sorts of ways where you might want to, if you have, especially let's say the named entity recognition. We talked about it a little bit. We did not use that in the notebook, but it's pretty popular. So if you have named entities and those, let's say, keywords that are, the keywords are the same concept, but different in different languages, you might want to build edges between them. That is one way that like multilingual support or multilingual stuff could use GraphRetriever. But again, that's sort of like me saying, let me find a problem that fits this solution. So if you have an actual, like a real life use case of that, happy to discuss that later. I think we're almost out of time, but yeah, that's a good question. Let's see. So on the question about DSE graph with billions of nodes, I'm not an expert on that. So please do shoot us an email or something after the live stream, and we can try to connect you with the right people that know that. And then let's see. Okay, last question. Does using edges have any impact on pricing or use of tokens? Well, I will say it does not. I mean, if you're using the Astra free tier, it really doesn't have any effect on this. The graph retriever stuff happens like essentially for free, like the graph stuff. It does, of course, when you then go back to use the LLM, you might have more results. And so if you're paying per token on your LLM calls, then you're going to have more stuff in there. But on the Astra side, on the query side, it really doesn't cost any more to use GraphRetriever. So I think that's it for now. It is 1 hour, so I think we're going to call it. But thank you, everybody, for joining for the live stream. Please do shoot us some messages after if you have any more questions. Check out the results. Check out the resources links. There's the notebook. There's the project page, documentation. There is Astra, free tier instructions, how to just sign up and use it. It's pretty cool. And some other links in there. We're going to send them out, I think, via email afterwards. And thank you again for watching. And yeah.